I'm going to start by finding the first derivative. To find the critical values, we have to take our first derivative and set it equal to 0. And then I'm going to factor out a 4x squared, or just a 4x, and I'm left with x squared minus 1. X squared minus 1 can factor again. It's the difference of two squares. I can set each piece equal to 0, each factor. So x equals 0, x equals negative 1, and x equals 1. So my critical values are negative 1, 0, and 1. So to test for the local max and min, and for increasing and decreasing intervals, I'm going to look at my derivative in between all my critical values. So I'm going to choose, let's say, negative 5, negative a half, 1/2, and 5 to plug into the derivative. So when I plug negative 5 in, I get a negative value. When I plug negative a half in, I get a positive, negative, and then positive. So that means f is decreasing, increasing, decreasing, and then increasing. So at negative 1 and 1, there's a minimum. And at 0, there's a maximum. But to find those y values, I'm going to go back to my original function and plug in the negative 1. And when I do that, I get a value of negative 1. Same thing when I plug in 1. So my local min is negative 1 at x is negative 1 or 1. And when I plug in 0, we get 0. So our max is 0 when x is 0. I'm increasing between negative 1 and 0, and again from 1 to infinity. We're decreasing from negative infinity to negative 1, and from 0 to 1. So now for the second derivative, I'm going to take the derivative of the first derivative. To find my other key values here, I'm going to set the second derivative equal to 0. And solve. So x is plus or minus 1 over root 3. So when I make my chart for the second derivative, I'm going to look at negative 1 over root 3. And positive 1 over root 3. And I'm going to choose, just to be sure, negative 10, 0, and positive 10. And when I plug those into the second derivative, I get a positive, a negative, and a positive. So that means f is concave up, concave down, and then concave up. Because the concavity changes, I have an inflection point at negative 1 root 3 and some y value, and again at 1 over root 3. But I have to find those y values by plugging 1 over root 3 back into the original of f of x. And when I plug in positive 1 over root 3, I get negative 5/9. I'm going to do the same thing for negative 1 over root 3, and we get negative 7/9. So then for my concavity, we're concave up from negative infinity to negative 1 over root 3, and again from 1 over root 3 to infinity. And it's concave down between negative 1 over root 3 to 1 over root 3.